Now we start the next session of the probability is independent events. What is an independent event? Actually, independent event means suppose A and B are two events associated with the sample space S. The probability of one of the event cannot occur the probability of the other event. I mean second event B. Then A, the probability of the event A cannot occur the probability of the event B. Then A and B are to be independent. For example, when a coin is tossed twice, the probability getting a head on the first toss is 1 by 2. And the probability getting a head on the second toss is also 1 by 2. That means the probability getting the head on the second toss cannot occur the probability getting the first toss. That means they are independent event. Now the second example. The Indian cricket captain has lost the toss in last 10 match. Then what is the probability he is winning the toss in the next match? Is also half chance, that is 1 by 2. That means winning the toss, the probability of winning the toss cannot occur the probability of tossing the he tossed the coin. That means cannot occur, that means they are independent. Winning the toss and tossing the coins are winning the match and tossing the coins are cannot occur, that means they are independent events. Similarly, write one more example. Suppose a bag contains 4 red and 3 blue balls. A bag contains 4 red and 3 blue balls. The probability of drawing, we draw 2 balls from the bag. We draw 2 balls from the bag. The probability of drawing a red ball is 4 by 7. Here probability of drawing a red ball, probability of drawing a red ball, probability of drawing a red ball is 4 divided by total outcome is 7. Now we draw a second ball. There exist 2 cases. In first case, when we draw a second ball after replacing the first ball, first we draw a ball and we draw a second ball after replacing the second ball, then probability of drawing the red ball is probability of drawing the red ball, a red ball, probability of drawing a red ball. Answer is again we get same answer 4 by 7. In second case, when we draw a second ball without replacing the first ball, we draw a red ball without replacing the second ball. Therefore, there are 3 red and 3 blue balls, and therefore probability of drawing the second red ball is probability of drawing a second red ball is answer is 3 divided by 7. That means in the first case, these 2 events, that is probability drawing a red ball in the first case and probability drawing a red ball in the second case, they are same probability. That means one cannot occur the second. But in second case, when the ball is replaced, when one ball is drawn and which is replaced, then we select the second ball. At that time, the probability will be occurred. That means they are not. In the first case, they are independent. In the second case, they are dependent. Okay, these are some examples for independent event. Actually, independent event is directly found is very difficult. In there, so here we definition use cheyyunnundu. Using that definition, we can confirm that given events are independent or not. Our definition says that if A and B are 2 events, if capital A and capital B are 2 events, capital A and capital B are 2 events associated with a sample space, S, then P of A intersection B is equal to P of A into P of B, then therefore A and B are said to be independent. Therefore A and B are said to be independent. This is a simple technique for finding given events are independent or not. A and B എന്നുള്ള ടു ഇവൻറ്റ്സ് കൺസിഡർ ചെയ്താൽ അത് ഇൻഡിപെൻഡൻ്റ് ആണോ അല്ലയോ എന്ന് ചെക്ക് ചെയ്യാനായിട്ടുള്ള സിമ്പിൾ മെത്തേഡ് ഈസ് പി ഓഫ് എ ഇൻ്റർസെക്ഷൻ ബി ഈസ് ഈക്വൽ ടു പി ഓഫ് എ ഇൻറ്റു പി ഓഫ് ബി എന്ന് എക്സ്പ്രസ് ചെയ്യാൻ കഴിഞ്ഞാൽ ദെൻ ദ ഇവൻറ്റ്സ് ആർ സെഡ് ടു ബി ഇൻഡിപെൻഡൻറ്റ്. P of A intersection B is equal to P of A into P of B, then the events are said to be independent events. Now we will discuss some problem based on this concept. Our first question: if P of A is equal to 3 by 5, P of A is equal to 3 divided by 5, P of B is equal to 1 divided by 5. Find P of A intersection B. Find P of A intersection B if A and B are independent. If A and B are independent. You know the condition. Since A and B are independent, A and B are independent. You know the condition is P of A intersection B can be expressed as P of A into P of B is equal to, we get answer 3 by 5 into 1 by 5 is equal to, we get answer 3 divided by 25. That's all. It's a very simple question. Okay, our next question is if P of A is equal to 3 divided by 5, P of A is equal to 3 divided by 5, P of B is equal to 3 divided by 10, P of A intersection B is equal to 1 by 5. Our question is, are A and B are independent? Are A and B are independent? Here we find P of A into P of B is equal to 3 divided by 5 into 3 divided by 10 is equal to, we get answer 3 into 3, 9 divided by 50. 9 divided by 50 is not equal to P of A intersection B. Therefore, our events A and B are not independent. A and B are not independent. If P of A into P of B is equal to P of A intersection B, then we get A and B are independent. Okay, our next question. A and B are independent events. A and B are independent events with the P of A is equal to 0.3, P of B is equal to 0.4, P of B is equal to 0.4. Questions are: find P of A intersection B, P of A intersection B. Second question, P of A union B, P of A union B. Third question, P of A given B. And fourth question is P of B given A. Here given P of A is equal to 0.3, P of B is equal to 0.4. Find P of A intersection B, P of A union B, P of A given B, P of B given A. Here given A and B are independents. Since A and B are independents, our first question, P of A intersection B can be expressed as P of A intersection B is equal to P of A into P of B. You know here P of A is 0.3 into 0.4 is equal to, we get answer 0.12. 0.12. Now the second question, find P of A union B. You know actually P of A union B formula is P of A plus P of B minus P of A intersection B is equal to, here P of A plus P of B minus, here since A and B are independent, therefore P of A intersection B can be expressed as P of A into P of B. Here P of A is equal to 0.3 plus P of B 0.4 minus 0.12 is equal to, we get answer 0.58. Now the third question, find P of A given B. You know the conditional for probability definition, P of A intersection B divided by P of B. You know since A and B are independent, P of A intersection B can be expressed as P of A into P of B divided by P of B. Here P of B cancel, we get answer P of A. What is P of A? 0.3. 0.3. And last question is P of B given A is equal to, using definition, right? P of A intersection B divided by P of A. Since A and B are independent, therefore P of A intersection B can be written as P of A into P of B divided by P of A. Here also P of A cancel, we get answer P of B. You know P of B answer is 0.4. That's all. It's a very simple question. First of all, we understand the concept of independent events. Since the two events A and B are independent, then P of A intersection B can be expressed as P of A into P of B. Next question. Given P of A is equal to 1 by 2. Given A and B are two events and P of A is equal to 1 by 2. P of A union B is equal to, P of A union B is equal to 3 divided by 5. P of A union B is equal to 3 by 5. And P of B is equal to, P of B is equal to P. P of B is equal to P. Find P. There exists two questions. First is, if A and B are mutually exclusive, if A and B are mutually exclusive. And second question, A and B are independent. A and B are independent. Okay, here given P of A is equal to 1 by 2, P of A union B is equal to 3 by 5 and P of B is equal to P. Find P, there is two conditions. Two conditions which two way നമുക്ക് P ന്റെ value കണ്ടുപിടിക്കുക. First is A and B are mutually exclusive and second is A and B are independent. You actually know what is mutually exclusive. When two events A and B are mutually exclusive, then A intersection B is equal to 5 and their probability becomes 0. Here, first of all, you write the formula P of A union B. You know P of A union B is equal to P of A plus P of B minus 0. Because A and B are mutually exclusive, therefore P of A intersection B is equal to 0. Because A intersection B equal to 5 and its probability becomes 0. Therefore, we get answer P of A union B is already given 3 divided by 5 is equal to P of A is 1 by 2 plus P of B corresponds to P. And therefore, P is equal to 3 by 5 minus 1 by 2. Here LCM is 10, cross multiplying we get answer 6 minus 5, answer is 1, that is 1 by 10. Now, the second question. If A and B are independent, P of A union B can be expressed as P of A plus P of B minus P of A intersection B is equal to P of A into P of B because A and B are independent. Here P of A union B is already given 3 divided by 5. P of A is also given 1 by 2. P of B is P. P P of A into P of B means 1 by 2 into P, that is P by 2. That is 3 divided by 5 minus 1 by 2 is equal to P minus P by 2 is again P by 2. That implies 6 minus 5, that is 1 by 10 is equal to P by 2. That implies P is equal to, answer is, we get answer 1 by 5. That's all. If A and B are mutually exclusive, then we get P is equal to 1 by 10. And if A and B are independent event, then we get answer 1 by 5. Since A and B are mutually exclusive, here intersection part becomes 0 because since A and B are mutually exclusive, A intersection B is equal to null set, null event, and therefore the probability of that null event becomes 0. So third part becomes 0 using this formula. Therefore P of A union B is equal to, we get P of A plus P of B. Here P of A union B is already given 3 by 5. P of A is already given 1 by 2 and P of B is also P. Using this we get answer P is equal to 1 by 10. Okay. Now we will discuss one more question based on the concept of independent event. Next is 13.2 exercise, NCERT 13.2 exercise, question number 5. Question number 5. Our question is also question number 5. The question is, a die mark 1, 2, 3 in red, a die mark 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let capital A be the event, the number is even, and B be the event, number is red. Are A and B independent? Actually, a die is thrown. Possible outcomes are, you already know, 1, 2, 3, 4, 5 and 6. Also given 1, 2, 3 is red. Here 1, 2, 3 is red. And 4, 5, 6. 4, 5, 6 is color is green. 1, 2, 3 is red and 4, 5, 6 is green. Okay. And A be the event. A be the event that number is even. The number even are 2, 4 and 6. B be the event that number is red. The red numbers are 1, 2 and 3. Okay. Here P of A is equal to, we know answer is 3 by 6. P of B is also 3 divided by 6. Now we find A intersection B. A intersection B, there is only one element 2 and their corresponding probability P of A intersection B is equal to, we get answer 1 by 6. Here P of A into P of B is equal to 3 by 6 is 1 by 2 into 1 by 2 is equal to 1 divided by 4. That means P of A intersection B is not equal to P of A into P of B, and therefore the given events A and B are not independent. Here to check whether the givens are independent or not. Here A and B are not independent. Okay. Now discuss one more question based on this concept. Our next question is question number 4. Question number 4. A fair coin and an unbiased dice are tossed. Same exercise 13.2, question number 4 is some difficult question. A fair coin and an unbiased dice are tossed. This question is similar to our special problem on conditional probability. Conditional probability, we second video special problem discuss how to create this type of event. A fair coin and unbiased dice are tossed. That A be the event, head appears on the coin, and B be the event, 3 on the die. Check whether A and B are independent or not. First of all, we create the sample space. A coin and a die is thrown. Fair coin, a coin and an unbiased die is tossed. When a coin toss and a die is thrown, that is, we get the possible elements are H1, H2, H3, H4, H5, H6, then T1, T2, T3, T4, T5 and T6. Therefore, the possible outcomes are H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Okay. Now, the first event, let A be the event, head appears on the coin. Head appears on the coin, that is called A. That is, the possible elements are H1, H2, H3, H4, H5 and H6. Head appears on the coin. And second, B be the event, 3 on the dice. 3 on the dice means H3 and T3. Check whether the events are independent or not. You know, the probability of the first event is, the first element probability getting head is 1 by 2 and probability getting 1 is 1 by 6 is equal to 1 divided by 12. Here there exists 1, 2, 3, 4, 5, 6 element and the probability getting A is 1 by 12 plus 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 1 by 12 is equal to 6 divided by 12. And probability getting B, answer is again 1 by 12 plus 1 by 12, that is 2 divided by 12. Now, what is A intersection B? A intersection B is equal to, we get answer H3. A intersection B is equal to H3 and their corresponding probability P of A intersection B is answer is 1 divided by 12. What is P of A into P of B? P of A into P of B is equal to 6 by 12 into 2 divided by 12. Here 12 cancel, equal to we get answer 1 by 12 is equal to P of A intersection B, and therefore A and B are independents. A and B are independents. That's all. Okay. Here A and B are not independent. Here A and B are independent. Okay. Now we will discuss one more question based on this concept. Next question is, given two events A and B. Given two events A and B. Seventh question, given two events A and B such that P of A is equal to 0. Events such that P of A is equal to 1 by 4. P of A is equal to 1 by 4. P of B is equal to 1 by 2. And P of A intersection B, P of A intersection B is equal to 1 by 8. Find P of not A and not B. Find P of not A and not B. Here P of A into P of B is equal to, we get answer 1 by 4 into 1 by 2 is equal to 1 by 8 is equal to P of A intersection B. That means A and B are independent. A and B are independent. Now we find P of not A and not B is equal to, not A means A complement, intersection B complement. Since A and B are independent, P of A intersection B can be expressed as P of A into P of B. Similarly, P of A complement intersection B complement is also expressed as P of A complement into P of B complement. Here P of A complement intersection P of B complement is equal to P of A complement into P of B complement, because A and B are independent. Also, you know what is A complement? Probability of A complement is already, you know, in the first year class we discussed what is P of A complement means 1 minus P of A. You know the total probability is 1. This is A in the event the probability minus him, we get a complement event probability. That is P of A complement is equal to 1 minus P of A is equal to here 1 minus P of A into P of B complement is also 1 minus P of B is equal to 1 minus 1 by 4 into 1 minus 1 by 2 is equal to 3 by 4 into 1 by 2 is equal to, we get answer 3 divided by 8. 3 divided by 8. Okay. Our next question is question number 14. Question number 14. Same exercise, that is 13.2. 13.2. Question number 14. Our question is question number 8. Probability of solving a specific problem independently by A and B are. Probability of solving a specific problem independently by A and B are 1 by 2 and 1 by 3. That is P of A is equal to 1 by 2 and P of B is equal to 1 by 3. If both try to solve the problem independently, find the probability that the problem is solved. First question and second question is exactly one of them solved the problem. Here the probability solving problem solving experiment are always independent events. Here probability solving a specific problem independently by two events are A and B are already given 1 by 2 and 1 by 3. 1 by 2 and A ennulla event in the probability 1 by 2 and B event in the probability is 1 by 3 is already given. First question is find the probability that both of them are solved the problem. Our first question is probability of both solved the problem. Both solved the problem means both solved the problem means we find the probability of A union B. A or B solved the problem. That means both solved the problem means A or B solved the problem. That means we find P of A union B. You know P of A union B formula, P of A plus P of B minus P of A intersection B. Since A and B are independent, P of A intersection B can be expressed as P of A into P of B is equal to P of A is 1 by 2. P of B is 1 by 3 minus 1 by 2 into 1 by 3 is equal to, here 6 is the LCM, so 3 by 6 minus, plus 2 by 6 minus 1 by 6. 3 plus 2 5 minus 1 4 by 6, that is 2 divided by 3. Probability of solving the problem, answer is 2 by 3. Now the second question. Exactly one of them solved the problem. Exactly one of them solved the problem. Probability of exactly one of them solved the problem. Exactly one of them solved the problem. One of them solved the problem. Exactly one of them solved the problem. That means when A solved the problem, at that time B cannot be solved. That is probability of either A solved the problem but B cannot be solved. A solved B solved B. Or in a probability or is connected with the sign plus. Plus A solved ചെയ്യാതിരിക്കുമ്പോൾ ആര് സോൾവ് ചെയ്യും? B solved ചെയ്യും. There is two possibility. Exactly one of them solved the problem means either A solved the problem, at that time B solved ചെയ്യില്ല, or A solved ചെയ്യാതിരിക്കുമ്പോൾ B solved ചെയ്യും. There is two possibility. Or A intersection B complement or A complement intersection B. Here or is connected with the sign probability and or is connected with the plus and is connected with the into. P of A intersection B complement or A complement intersection B. That is, since A and B are independent, which is expressed as P of A into P of B complement plus P of A complement into P of B. P of A is 1 by 2 and P of B complement is 1 minus 1 by 3. 1 minus 1 by 3 plus P of A complement is 1 minus 1 by 2 and P of B is 1 by 3 is equal to 1 by 2 into 3 minus 1 2 by 3 plus 1 by 2 into 1 by 3 is equal to, here 2 plus 1 3 divided by 6 is equal to, answer is 1 by 2. Exactly one of them solved the problem, answer is 1 by 2. Exactly one of them means when A solved the problem, at that time B cannot be solved. Or second possibility, when A cannot be solved the problem, at that time B solved the problem. There is two possibilities. These two probability will be added. That here added. ഓർമ്മിച്ചുള്ള ഇത്തരം കേസിൽ വരുമ്പോൾ രണ്ട് പ്രോബിലിറ്റി നമ്മൾ ആഡ് ചെയ്തെടുക്കും. എ ഓർ ബി ആണ്. അപ്പോൾ എ സോൾവ് ചെയ്യുമ്പോൾ ബി സോൾവ് ചെയ്യായിരിക്കും. ഓറിന് നമ്മൾ പ്ലസ് ഇട്ടാൽ കണക്ട് ചെയ്യുക. ബി സോൾവ് ചെയ്യുമ്പോൾ എ സോൾവ് ചെയ്യായിരിക്കും. ഇപ്പോൾ സപ്പോസ് 3 ഇവൻറ്റ്സ് തരികയാണെങ്കിൽ എ ബി സി എടുക്കുമ്പോൾ എയും ബിയും സോൾവ് ചെയ്ത സമയത്ത് സി സോൾവ് ചെയ്യും. ഓർ പ്ലസ് എ സി സോൾവ് ചെയ്യുന്ന സമയത്ത് ബി സോൾവ് ചെയ്യും. ഓർ ബി സി സോൾവ് ചെയ്യുന്ന സമയത്ത് എ സോൾവ് ചെയ്യും. ദാറ്റ് ടൈപ്പ് പ്രോബ്ലം വിൽ ബി ഡിസ്കസ് ലേറ്റർ. Okay, now discuss on last one more question we will discuss based on independent events. Okay, 9th question. Next question is, given two events A and B are independent events. Given A and B are two independent events such that P of A is equal to 0.3, P of B is equal to 0.6. Find, question number 1, P of A and B. P of A and B. Question number 2, P of A and not B. P of A and not B. Then third question. Our third question is P of A or B. P of A or B. Then fourth question is P of neither A nor B. Neither A nor B. Okay, here given A and B are independent. Okay, our first question, P of A and B. That means we find P of A intersection B. You know, when A and B are independent, P of A intersection B can be expressed as P of A into P of B is equal to 0.3 into 0.6 is equal to 0.18. 0.18. Okay, next question is P of A and not B. P of A and not B is equal to P of A intersection B complement. Since they are independent, it can be expressed as P of A into P of B complement. What is P of? That is P of A into 1 minus P of B is equal to, you know, P of A is 0.3 into 1 minus 0.6 is 0.4 is equal to 0.12. 0.12. Our third question is P of A or B is equal to P of A union B is equal to, you know, formula P of A plus P of B minus P of A into P of B, because A and B are independent. Here 0.3 plus 0.6 minus 0.18 is equal to, we get answer 0.72. Then our last question is P of neither A nor B. 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 Then P of A complement intersection B complement. You know, since A and B are independent, P of A complement intersection B complement can be expressed as P of A complement into P of B complement. You know, P of A complement means 1 minus P of A into 1 minus P of B. You know, P of A is 0.3, that is 1 minus 0.3 is 0.7 and 1 minus 0.6 is 0.4. We get answer 0.28. Okay, on next video we will discuss our next topic. That's all. Bye.